Hi, I'm Venu.
And I'm Mohit.
This is our demonstration video for our project for EE4455.
Our project is called a perimeter breach alarm for object tracking. Our project triggers an alarm whenever a tracked object leaves a specified boundary and also sends a SMS to the owner of the object.
An application of such a project could be in object tracking of pets or of babies, so that they are within a pre-specified boundary and do not go outside it.
Or even to track costly items to prevent thefts.
So let's look at the various components that we used in our project. First is a pair of XB for wireless transmission of data. One of these XBs is placed on the ground station and the other on the object that we are trying to track. The signal strength of the data transfer between these two is used to compute the distance between them, and whenever the distance is greater than the pre-specified boundary, we trigger the alarm. All this computation is done by the Arduino Uno board, and the interrupt is generated to be passed on to the National Instruments MyDAC. Now this interrupt can be seen through the glowing of the LED, and finally the interrupt that is received by the NI MyDAC is interpreted by the LabVIEW software, which triggers the alarm. This project consists of two parts. The first part is the programming of the XB using XCTU and the programming of the Arduino using the Arduino environment. This was contributed by me to the project. My friend's contribution included developing the VI to trigger the alarm as well as to send the SMS. This VI consists of an LED which glows green when the object is within range and turns red when object goes out of the range. It also consists of a numeric input which takes in the phone number to whom the SMS has to be sent. There is a reset button too in order to reset the alarm once the object is back within range. But if the alarm has to be disabled when the object is outside, we have a pass key which allows the user to enter a password to stop the alarm.
Now let us show you a demonstration of our project. Here we have an Arduino which computes the distance between the ground station and the object being tracked, which in this case is my friend Venu. On this computer we can see the signal strength being calculated, while on the other computer we can see the alarm control VI, which shows a green LED, which means that the object is inside the range in which the object is being tracked. Now let us see what happens when the object moves inside the range. I'll ask my friend Venu to move inside the room. As you can see, the object is moving inside the room, and on the alarm VI, the green LED maintains its state. Now let us see what happens when the object leaves the room. I'll ask my friend Venu to leave the room. So Venu has left the room, and as you can see, the alarm has started ringing. Also within 5 seconds, we expect an SMS on the phone. We just received an SMS on the phone informing us that the object is outside the range. Now I want to reset the alarm. Let's see what happens when I try to reset the alarm. When I try to reset the alarm, it does not reset. For resetting the alarm, I need to call the object back inside the room. So the object is back inside the room now. And as you can see, we can reset the alarm. The LED on the alarm control VI has turned from red to green, which indicates that the object is within the room again. Now let us see what happens when the object is outside the room and we want to shut down the LI or turn off the alarm. I'll ask my friend Venu to leave the room again. So Venu has left the room and the alarm has started ringing again. Within 5 seconds again we expect a SMS. We just received an SMS telling us that the object is outside the room. Now suppose we want to switch off the alarm at this point of time. As you can see at the alarm control VI, towards the bottom right there is a numeric keypad. In the numeric keypad we need to press in a secret code which only the owner of the object knows. The secret code in this case is 1234. And as soon as I input the secret code, the alarm switches off.
Let's now look at our project in a little more detail. First, for the programming of the XPs. Now, to make the XPs talk to each other, we configure them using the XCTU console. We selected a baud rate of 9600 bits per second with no hardware flow control, 8 data bits of transmission per serial packet with no parity bits, and one stop bit to signal the end of every serial packet. Next, for the modem configuration, one of the XPs was selected to be the router and the other to be the coordinator. The router was the one that was placed in the ground station on top of the Arduino, and the other was the coordinator, which was on the object being tracked. Appropriate function sets were burnt into these XP modules using this option. Three of the most important configurations that we set for the XPs were the destination address of each of them were made to be the address of the other to enable a point-to-point communication between the two XPs. The next configuration was the input-output settings, where we transmit dummy data between the XPs to ensure that they do not power off due to power conservation. For this, 3 digital pins were sampled using the ADC at a sampling rate of 80 milliseconds per sample, and the data of this was transmitted between the XPs. But what is more important is the signal strength of this transmission that we used in our project. Now, to interpret the signal strength, we programmed the Arduino Uno using the Arduino programming environment. We first set up a serial communication between the Arduino as well as the XP through the serial pin. This happens at the baud rate of 9600 bits per second. Next, we continuously read the data that is being received at the XP and check for a valid response. When we get a valid response, we then extract out the received signal strength intensity and compare it with a threshold to decide whether the object is within the room or outside the room. Now, this threshold will change from room to room, and the 73 dB that you see here was the value experimentally found for the room in which we conducted the demonstration. When the threshold exceeds this, we deem that the object is outside the room, and when it is within this threshold, we deem that the object is within the room. So, if it is outside, we trigger a high on the digital pin, and if it's inside, we trigger a low on the digital pin. A third scenario would be if there's no communication at all between the two XPs. In this case, we again decide that the XPs have gone outside the range and hence trigger a high in the digital pin. Now, this high value, which is the interrupt value, would be passed on to the NI MIDAC to be further processed by the lab view in order to trigger the alarm.
Now let us start our discussion by looking at the front panel of the alarm control VI. The front panel consists of 4 sub-panels: sub-panel 1, sub-panel 2, sub-panel 3, and sub-panel 4. In the first sub-panel, we lay down the instructions on how to get the alarm control system running. So let's follow these instructions. We first set up and power the hardware, which consists of the ZigBees and the Arduino. Then we input the hand phone number in the second sub-panel. After that, we start the VI. This also starts the alarm. A green LED light indicates that the object is within the range. Now let us see what happens when the object moves outside the range. As you saw, as the object moved outside the range, it triggered the alarm. After the object came back inside the range, we press the reset button to stop the alarm. Now, let us assume that we want to switch off the alarm when the object is outside the range. This can only be done by the owner of the object, and he needs to input a secret passcode in the subpanel number 4. The secret passcode in this case is 1, 2, 3, and 4. So let me show you a demonstration. Assume that the object moves outside and the alarm starts playing. As you saw, I input the secret passcode in the numeric keypad in subpanel number 4. This stopped the alarm and also the VI. Now I'll give you an explanation of the block diagram. So let's look at the block diagram. In the block diagram, we have the MyDAC assistant, which is used to continuously poll for data on one of its digital input pins. If the digital input pin is low, the LED continues to be green and nothing happens. You can see this by the false case structure over here. However, when we receive a digital input as high, known as the interrupt, then the LED turns red and also the true event of the case structure is executed. When the interrupt is triggered, we immediately send a SMS to the owner. This is done by sending a HTTP request to a SMS gateway that we have already set up beforehand. It sends the message object out of range to the owner through the SMS. Here we can see that the HTTP URL is concatenated with the input handphone number and the input message, and the HTTP request is executed and sent to the SMS gateway. Now you must have noticed that we have a while loop inside the case structure. So this is the while loop. The while loop is used to continuously sound the alarm, which is in this flat sequence structure. You can see the alarm, and it's taking a file which is defined over here where the file is located, and it rings the alarm using the while loop and also this flat sequence structure. The loop has another purpose. We notice an event structure in the loop, which can be seen here at the bottom part of the loop. The event structure has two events, the timeout event and the value change events. When the user wants to switch off the alarm, he inputs a secret code, which is input using these values over here. And these values are converted to a decimal string and stored in the shift register of the loop. When the value of the shift register matches a predefined value, which is shown here to be 1, 2, 3, 4, then the loop terminates, which is shown over here. So the loop terminates. At the same time, we stop the execution of the program. And this is how the block diagram explains how our front panel works. Thank you for watching this presentation. If you have any questions, please email us at mohi0002@e.ntu.edu.sg or venu0008@e.ntu.edu.sg. Thank you once again.